Here we are with a question all about calculating current. We're told that we've got resistors, which are 2 ohms, and they're connected in this kind of slightly complicated series and parallel combination. Cell has an EMF of 3 volts, negligible at internal resistance, and the ammeter also has no resistance. So take a second to have a try, and then we'll see what the answer is. Now, if you're anything like me, you probably completely overthought this question. This question is incredibly easy when you make one small realization. And when I first looked at it, I thought I was going to have to think about adding up these resistors in the top line here, and the fact that we've got 6 ohms here, 2 ohms on the bottom. We're going to calculate the total resistance. But then we remember one thing about series and parallel circuits, particularly parallel ones, is that the potential difference between these 2 points is always the same. And so therefore, if we're looking at our 3 volt supply, we know the potential difference between points, let's call them A and B, must be 3 volts. And what that means is that the potential difference across this bottom resistor must also be 3 volts. We know its resistance, and so therefore all we have to do here to calculate the answer is simply take the ratio of the two, 3 over 2, to get 1.5 amps. Now, as I say, you could massively overthink this. You could calculate the current drawn by the supply, think about how much of that goes in the first branch, how much of it goes in the second, and you get the same answer. But this is one of those ones where you just take a deep breath, have a think, try the equations, and then you'll probably get the right answer. Okay, now obviously it's easy enough for me. I've done these plenty of times, had a lot of time to think about it, and in the exam, students don't always think that way. But just be aware, sometimes your questions aren't expecting you to work through multiple equations. You're just being asked to analyze the situation and come up with the simplest solution, which in this case is C.